Visitors from throughout Southern California often park their beach chairs and fishing gear on the narrow stretch of rocky sand that surrounds the Big Bear Solar Observatory, as it juts into Big Bear Lake from the north shore. Few realize that the mysterious, white-domed facility behind them is home to one of the highest-resolution solar telescopes in the world, or that a team of 14 experts keeps that telescope trained on the sun whenever it's shining. And few know that the images and data captured by the observatory over the past half-century have helped scientists unlock numerous mysteries about the star that powers our solar system, giving us a better understanding of the sun's oscillations and magnetic fields, and other solar phenomena with who. It's not easy to translate much of that research into terms the general public can appreciate. That's likely why, though more than 200 articles citing data from the Big Bear Observatory have been published in scientific journals just in the past 2 years, even many locals don't know much about what goes on inside the observatory. But Wenda Cao, a physics professor and director of the Big Bear Solar Observatory, hopes a current project, which will expand the site's purpose from one centered on discovery to one that includes practical applications, might change that. After some recent upgrades, the observatory's main telescope is offering a continuous feed of high-resolution images of electromagnetic storms taking place on the Sun, and what that ball of glowing gas 93 million miles away looks like just before those storms get started. Another, recently installed telescope will soon help collect long-term measurements of solar magnetic fields. And yet another is one of 6 in the world that helps to capture images of the Sun 24 hours a day. When this data is considered together, Cao and his team hope to identify patterns that could lead to an early warning system for solar storms. Such a system could help travelers better plan to see the northern lights, which are triggered by solar storms. But it would also function much like systems that now warn us about coming tornadoes or hurricanes, offering a heads-up to help minimize damage caused by solar flares and mass solar ejections. Such events can take out electrical grids, disrupt satellites and radios, put astronauts at risk and deliver an elevated dose of radiation to people on commercial flights in the North and South Poles. That will be the holy grail of space weather predictions, said Antti Pulkkinen, director of the